I want everybody to go to Desmos.
Oh, I already had a tab open for that, and I didn't.
It'll take you a second. You go to Desmos. There should be a link on the Canvas homepage.
I always have it. I have a bookmark.
I forgot that was a thing.
It's more like Pesmos.
Everybody there?
No.
Yes.
You're going to click Start Graphing.
Oh, mine's already in the graph.
Well, clear whatever you've got in.
There's nothing.
Okay.
I have a bookmark as just this.
Everybody have what my screen is showing? Okay. So what I want you to do is just type in an equation, and I'll give it to you. Y equals 3x plus 2. 2.
I remember doing this.
Y equals 3x plus 2. Everybody have that in?
Yep.
Okay. We can look at this graph and kind of review what we've been learning. Okay. When it's in this form, it's called slope-intercept form. And when it's in slope-intercept form, the thing that's extremely obvious to you, or should be at this point, is what the slope of the line is and what the y-intercept is. The y-intercept, again, is the point that line crosses the y-axis. If I look at this graph, the y-intercept is 2, and sure enough, that number is 2. And also when I look at this graph, I can pick 2 points. So I'll pick this point here at 0, 2, and I'll pick 2, 8. Do you see that those two go through perfectly at an intersection? So if I look at those 2 points, it goes up 1, 2, 3. Is that right? Up 2, 3, and up 6. Sorry, it goes from 2 to 8, so it's up 6 over 2. 6 divided by 2 is 3, which is the slope, m, of this line. Okay, just a review. So when it's in slope-intercept form, you can see the slope, which is your rise over run, and you can see your y-intercept. Okay? Now, everybody on the next line, go ahead and graph. So you just hit enter, and a new space comes up. Y equals, maybe.
It was okay that I used this for some of my web work questions, right? Because I've done that.
3x plus negative 2, or sorry, 3x minus 2. Let's do that one.
Dude, that's crazy.
3x minus 2.
Same slope.
Okay,
Still 3.
so it's the same slope, different y-intercept. What's interesting about these two lines is they are parallel. They will never cross. You can go out to infinity as far as you want, left or right, positive or negative direction. These two lines will never intersect. They are called parallel lines. Okay, what do you notice that is the same about these two lines, the equations? Their slope. So I wanted to illustrate this for you, okay, to let you know that when you have two lines that have the same slope, those two lines are parallel. They're parallel. Okay? Now go ahead and delete one of these. Just delete the second one. And then we'll just hit enter again. Type in y equals negative 1/3 x plus 2. Don't do that.
Don't forget to press over on the arrow key. Plus or minus.
Whoa.
Plus.
That did not work.
Negative 1/3 x. After you do the negative 1/3, press your right arrow button so it pops back up.
Oh, I didn't press that, but you didn't put X.
Now that was a helicopter blade. So helicopters are.
Wait.
Negative
Oh,
1/3.
it does curve. That's cool.
X has to go. X has to go in the numerator.
Mine doesn't curve.
See,
curves.
if you do this,
Yeah, because you did it right.
it curves.
Yeah. Those are called rational functions, and we'll talk about rational functions at the end of this class.
Oh.
Not this period.
Oh.
At the end of the
You
year.
meant this period.
Rational functions, no.
This is so
Right now we're talking about lines. Okay, so there is a little trick into getting it to actually record what.
The lines were curved. See? Look.
When x is in the denominator.
Oh,
Okay. Everybody have this graph, negative 1/3 x plus 2. Okay, y-intercept is still 2, right?
Yeah.
These two lines are perpendicular to each other. What do you notice about their slope?
It's exact opposite.
Well, it's exact opposite, and opposite means change in sign. Opposite means change in sign.
The negative side.
It's opposite and the inverse. So it's both of those. It's not one or the other. It's both. It has to be the opposite sign and the inverse. So if it originally was 1/3, the inverse of that is 3/1, or just 3. If it originally was negative, then the perpendicular's got to be positive. So it's both of those combinations. Okay, I wanted to just show you illustration-wise why the opposite inverse slope gives you a line that's perpendicular. Okay, this program is really cool. It's one you can use the rest of the year if you want. You've got it available.
Give us the slope for, like, if you,
Now it looks like it has.
like, if you say y equals 3x plus 2, can you somehow ask it to give you the?
No. No. Okay, so on to what we're talking about today. You're going to be able to, at the end of this section, be able to tell me the equation of a line if I give you a slope and a point that I want that line to go through. So as an example, let's say I want to find the equation of the line. I guess I'm going to use green. I want to find the equation of the line that's perpendicular to this line that goes through these 2 points at the point, I don't know. No, I want to do 2, 4. I don't know. I'm making one up. We'll see if it works. I want to find the equation of a line that's perpendicular to this line that goes through this point. Okay, that's why I'm teaching this, so we can learn how to do it. Okay, so the first thing you need to do is find the equation of your original line. This is what we worked on in the last section. First thing you do to do that is you find the slope. 6 minus 3, 2 minus 1. My slope is 1. 3, sorry. Sorry. So I know this much so far about my line, right? Now I'm going to pick either point, because both points are on this line, and I'm going to plug those in for x and y. So 3 equals 3 times 1 plus b, right? There's my x and y. Okay, so now I'm going to subtract 3. My b is 0, right? So the equation of this line is y equals 3x. Okay, so I want to find the equation of the line perpendicular to this one that goes through that point, 412. When we look at our Desmos, I could find, let me find it again here. Let's go ahead and change that y-intercept to, I don't know, 7. Same slope, I just changed it to 7. Do you see how these two lines do not have the same y-intercept? One of them has the y-intercept of 2, and one of them has the y-intercept of 7. So to find a line that's perpendicular to another line, the y-intercepts don't always have to be the same. The last one we had in there, plus 2, it actually was the same. But it doesn't have to. Okay, so if I want to find the equation of a line that's perpendicular to this one, the only thing I really need from this line is its slope. That's the only thing that's relative to the perpendicular line I'm trying to find. The y-intercept, if there was a number here, there isn't. But if there was a number here, I don't care what it is because it doesn't matter. My new line is going to have a different y-intercept, or could. Okay, so all I really care about is the slope. And what I'm going to do with the slope is convert it to a slope that's perpendicular to this line. And how do I do that? We just went over that.
Reverse Inverse and
Opposite, both. So inverse of this and opposite is negative 1/3, right? Okay, now the problem is I don't know b. And again, it is not the same as the b in the original line. We can see that from our graph on Desmos. These two lines are perpendicular, but they don't have the same y-intercept. So using the y-intercept from my original line is not going to help me. The only thing I need from my original line is the slope. And once I know the slope, now I'm going to use this equation where it's the opposite and inverse and the point I'm given. And I'm going to do the same thing with this line as I had to do with this one to find B. I'm going to use 412. To find B. Okay, remember this is negative 4/3, right? Because this is 3/1 or 4/1. Now, those of you who love fractions, keep working. Those of you who don't, what's a trick I can do here to eliminate the fractions? Yes, multiply it by 3. This becomes 36 equals negative 4 plus 3b. Much easier to work with. You just have to remember you've got to do it to every term. If you're going to use this trick, you've got to do it to every term or you're going to get yourself in trouble. Okay, now we solve. We're going to add 4. 4. And solve for b. And I can leave it like that. That's b. So the equation for the line that's perpendicular to my original. So on Desmos, perpendicular to the line that goes through these 2 points. So on Desmos, everybody clear your screens. Type in your original line, y equals 3x.
Just 3x.
Y equals 3x. That's what we found our original line to be. Y equals 3x. Everybody type that? Now type the line we just found to be perpendicular. Y equals negative 1/3 x plus 40/3. Y equals negative 1/3 x plus 40/3. And I'll do it real quick.
Negative 1/3 x and 14.
That does look pretty perpendicular.
Where's my line at? Okay. So the question I have, what was the point that I wanted this new line to go through?
412.
412, does it? There's 4, there's 12.
Wait.
My purple line is my new line, and I wanted it to have a slope that was perpendicular to my original that went through the point 412. And it does. So you can use Desmos to check your work. You get an equation, you can plug it into Desmos and see, does it look perpendicular? Does it look parallel? Did I do it right? You have a question?
Oh, it's just something that I always thought that Desmos, if they had an option that you could keep the same like ratios, like it went up by 5s or by 2s, that you could lock that, so instead of when you scroll up, when you zoom out, it gets
Well, you can't zoom out if it stays the same scale.
Just put a dot on over
On
412.
Desmos?
Well, no, like I'm talking about in a graph. The easier
Uh-huh.
kind of just go to 412 and then put in your negative slope and then find your y-intercept from that.
You could, but our y-intercept was 40/3. That's pretty tough to find your y-intercept if it's not an integer. And they aren't always going to be integers. WebWork doesn't like integers that well. They like a lot of fractions, which is good because you guys don't like them, and the only way you're going to get better is to work problems with fractions.
Once we get the hang of it, can we go back to just
I work
integers?
with kids.
No.
You don't like them.
Okay, so now you guys try this one. I want the equation of a line that goes through these 2 points. I want the new equation to be parallel, the line to be parallel to this one, and it needs to go through the point and this will probably end up with fractions galore because I didn't try this on my own. I just threw numbers up. But I want you to find the equation of a line parallel to this one that goes through this point.
Wait, parallel?
Parallel. This time we're doing parallel. Parallel.
What if you're like, so it's like -2 and 2? Is that becomes a whole number, right?
Mhm.
So is it -1?
Mhm.
Pardon the interruption. Teachers, please dismiss the freshman volleyball players at this time. Good luck, girls.
Now what were we trying to do with that?
You're going to tell me the equation of the line that's parallel to this one that goes through that point.
I zoomed out to yours to get back.
Maybe what's it? That? B? So now you plug your y and x from one of those points in. So
Is
your
this
3
right?
is your x, so...
I don't know what the answer is yet. I'm going to do it. I made this up on the fly.
I'm just trying to see what the
Okay.
answer is.
Well, I'm pretty good then.
Well, I hope it's right. I don't know how to make it parallel.
Well, so then do I just plug
Wait, it's
in-
supposed to be parallel?
Oh, I
Yep.
plug in the
Okay,
points
so
that
it's the
I
same
need now
slope.
with the same slope.
Yeah, I'm not sure.
So...
You guys ready for me to start working on it?
Hold on, I gotta fix this on my own.
Okay,
I got
good.
I can do it. I think I did it. Let's see if this works.
Oh, because you're too set. How come I can do it on here? On the whiteboard.
Okay, so the first step here is finding the slope of this line. So I take 5 minus 7 over 3 minus 1. Y2 minus y1, x2 minus x1, right? -2 over 2, which is -1. So I know the equation will look like that. I don't have to put the 1 in, I just did it for illustration. Because if it's -1, you can just put negative x.
So that's what it's supposed to be.
That's-
We're supposed to figure out what B is.
Now we've got to figure out what b is. So we're going to use one of these points. I'll just use 1, 7. So 7 equals -1 plus b. b is equal to 8. So the equation of my first line is -x plus 8.
I don't know why I put -1x. It could just be -x. That's it.
So make sure you've caught up to me and you know what I did.
Okay.
Did everybody get this far
Yes.
correctly?
Yes.
Okay, wait, hold
Well, I
up.
just got the wrong
I got that
number
far.
and then I fixed it.
So that means it's cool.
Looks safe, y'all.
I used the other points and I said...
That's fine. You should get the same thing if you use the other set of points.
Like b equals 8?
Uh-huh. So if I use 3, 5,
Oh, yeah, I know what the problem is. Because I didn't have a negative slope, it was subtracted. So.
okay? This is a good illustration, though. I keep saying just pick one of the 2 points. This is why it doesn't matter which point you pick. You will get the same y-intercept because both those points are on the original line. Okay? So my equation now is y equals -x plus 8. This is the line I want to find another line parallel to that goes through the point 2, 7. Okay, so the key here is if it's parallel, the only thing I care about with this line is what its slope is. The slope of this line is -1. I could, and this would be a good habit to do, write it as a fraction, just because you're going to invert it when it's -1. It's not that difficult, but if it's -3 and you write it as a fraction, -3 over 1, it makes it easier to see what the inverse is. Does that make sense? Okay, so here, yes, I'm going to change the sign and flip it. Well, when I flip it, I still get 1. And when I change the sign, I get +1.
Why are
So,
we flipping it?
because we're, oh, you're right, we're finding the parallel. Parallel, I'm sorry, I scared myself. Parallel line. So, the slope of the new line will be -1. I don't know the y-intercept. And plus b, and I'm going to use the 0.27. There's the equation of my new line. If you graph both of them on Desmos, you will see they are parallel.
They are.
And you will also see your new line, -x plus 9, goes through the 0.27. It goes through the 0.27.
So perpendicular, I know it flips the
Yeah, that's
slope.
what I don't get about
Yeah, parallel has the same slope.
You just plug
So this
in-
is-
oh,
okay,
this is
so
what
you're
they
leaving
use
this
as-
up
oh,
first.
This is what they look like. Okay, that makes more sense.
So, I mean, we don't
Okay.
have to do this in Desmos. This is like the.
No, this is just a place for you that you can check your work if you want to.
Okay.
I mean, if you keep getting it wrong in web work, you might plug both of them into Desmos and see that line's clearly not parallel, or that line's clearly not perpendicular, so I did something wrong with my math. Okay, it's just another tool you can use. All right, but that's what this section is over, is finding lines that are perpendicular and parallel to other lines and finding their equations. Okay. Tomorrow, I will not be here. You will be going on to the next section, which is graphing lines in slope, intercept form, and standard form. What I think I'm going to do is go ahead and post the video that I recorded last year when I talked about this section. And so when you get in, I will let the sub know, I don't know who it is yet, that I want you guys to watch that. And if she or he can't pull it up on the board, come prepared tomorrow with some headphones so you can watch them. I do have some in my top drawer of I think the gray filing cabinet over there. So if someone forgets them, remind the sub that they're there for your use if you want them. Okay? Let's go through the textbook check real quick. I always forget to do this, and I want to go through it with you so we can talk about. We can get there. Okay, this was 2-4. No, 2-3. Not sure why I picked 2-4. Okay. So what is the slope of the line parallel to y equals -2?
It's 0 because there is
Yeah.
no slope there.
Right. Think about the line, though. What does the line equal y equals -2 look like?
It'd be -2 and then that.
And then there's just that there's.
Every point on that line, the y coordinate is -2. So it's a horizontal line. And the slope of horizontal lines are 0. Slope of vertical lines, if every coordinate on there was the same x value, that's a vertical line. Slope of vertical lines are undefined, not 0. Horizontal are 0, vertical lines are undefined.
So, okay, so if you get a vertical line,
It's undefined.
like writing it out.
You'll put, does not either, it'll probably say write undefined if that's what you get.
Okay.
Okay.
Then why-
As noted in the end of the video, when trying to find the equation of a line perpendicular or parallel to a given line, what information is not needed?
Intercept.
The y-intercept. You don't care what the y-intercept is. All you care about is the slope.
We don't want that.
Yep, don't get confused and think both lines have to have the same y-intercept. They don't. All you care about is the slope.
You know, I guess kick your dog.
Well, no, but the x-intercept's not part of the equation. The equation is slope and y-intercept. Question 3. The product of the slopes of two perpendicular lines is what?
2.
I didn't know this.
I didn't know so either. It got one.
-1.
Yep. Okay.
Why?
So
If you read the textbook.
if one slope is 3, what's the slope of a line perpendicular to this one?
-1/3.
-1/3. So if the product means I multiply those two together.
Yep.
When I multiply 3 times -1/3, I get -1.
I get it now.
So the product of the perpendicular slopes is always -1.
Should remember the textbook.
If the slope of a line is m, the slope of the perpendicular is -1 over m. Right? Opposite sign, inverse.
I thought I had
7, didn't you divide?
Oh, I think I put 1 over.
So it's no longer a fraction?
To find the equation of a line parallel or perpendicular to a given line through a given point, first use the slope of the given line to find the slope of the new line. Then you need to find the y-intercept of the new line. How do you find that?
Oh, it's the last one.
Well, the
Oh, wait,
answers are
no.
actually
Oh, they're
different
different.
order.
Oh.
Plug in the new slope and the given point and solve for b. Yep, that's the process. Okay?
You do the ones on WebWork,
Like what?
where like you're solving for a variable inside of parentheses.
Give me an example.
It's on
So,
number 1.
find the value of k so that the line containing the points 4, then -3, and k, and -6 are parallel to the lines containing -4, -6, -4, -6, and 1, -4.
1 comma what?
-4.
And we want these two lines to be parallel?
Yeah.
Okay, so you're going to find the slope of these two, which is what?
4 over 5, I think.
-4.
-2 plus 6 over 1 plus 4, which is 4 over 5. Right? Okay, and if they're parallel, that means the slope of this has to be the same. So you just set up an equation, -6 plus 3 over k minus 4, 4/5.
Even if you did do it backwards, it'd still be 4.
So that's -3
Minus 2.
over k minus 4
Oh, you would make it
equals
line.
4/5. How do I solve a problem like this? We had one on the quiz or the test. Cross multiply.
There's no possible.
So I have -3 times 5 equals 4
Just stop. It's okay.
times k minus 4. Now you can solve.
Okay.
Oh!
I think WebWork is close.
For 2.3.
Okay, I'll get that open. Okay,
2.3 or 2.2?
It'll tell you the answer.